Hi Jory, today we're going to be learning about 3.6, which is all on parallel lines. Remember, as usual, with geometry, you don't actually know anything until we are told it directly. So we are going to get several definitions today. The first definition is transversal. A transversal is a line or line segment that intersects at least two other lines. Now here we can see a transversal. It's already labeled and everything. Notice it goes through 1, 2. It could go through an infinite amount more. It can come at this angle, it can come at this angle, and these lines can also be at any angle. One other thing to keep in mind is note that it can intersect at any angle. Now, next thing we need to look at is corresponding angles. So corresponding angles are angles that are located at the same place on two different lines. Now, this is one of those things that's easier to see than it is to explain verbally. So I'm going to look at corresponding angles in regards to this picture up here. Now, on this picture, we have A and E labeled as corresponding angles. Now, this is because A is above the line and to the left of the transversal. So it's to the left and it's on the top. And E is to the left of the transversal and it's on top of the line. So that means they're corresponding angles. Now there are a lot of corresponding angles in this picture. We've got A and E, but we've also got B and F. We've got D and H. And last we do have C and G. All four of those are corresponding angles because they're located in the same place on different lines. That brings us to why this matters. Corresponding angles postulate tells us all about why corresponding angles even matter. So first, if two corresponding angles have the same measure, we can conclude that the lines are parallel. Thing to note here, parallel lines will now often be denoted as just two lines next to each other. And that's going to come up a lot in the mathematical shorthand. So rather than writing out this entire thing, a lot of times math is just going to do things like this. M for measure of for corresponding angles are equal. So if the measure of the corresponding angles are equal, that's what that says. It implies that the lines are parallel. So this is just shorthand. I'm not going to make you memorize the shorthand, and I'm not going to say on the test, oh, rewrite this in mathematical shorthand. Just keep in mind that you're going to see things like this more often, even in context of the book, and learning how to do the shorthand easily yourself while still being consistent, like M still standing for measure, angles being used instead of writing out angles. That's going to make your note taking a lot quicker, which is very helpful, especially if you're going on into college. Okay. If the lines are parallel, we have a second statement as well. If they are parallel, the corresponding angles have to have the same measure. So this is just saying if the lines are parallel, it implies that the measure of the corresponding angles is equal. Notice here we have a statement and the converse of the statement. Now, if both of these are true, which they are, I just told you. So if both of these are true, it means we have a biconditional. And this is the biconditional. I'm going to write it in shorthand because I don't want to rewrite the whole sentence. But lines are parallel if and only if the measure of corresponding angles are equal. All right, that leads us on to one final note here on this page. Segments or rays are going to be considered parallel if the lines containing them are parallel. And that just means, let's say we've got this ray and this ray. Now they look parallel, but it's pretty easy to see if you actually continue down the line. Hey, yep, the lines that contain them are parallel, which would mean this and this is parallel. Notice I have these little arrows within the full line. That is just notation for parallel lines. And on pictures you will see small arrows that will be drawn on the line, not at the end, but on the line. And that just tells you that you can assume those lines are parallel. For instance, lines M and N in this picture, we can assume are parallel because they both have small arrows on it. Now the arrows might look like these ones here. They might look like the ones I made here, so these ones could have been these small little triangle arrows. What you can assume are parallel is this. Remember the arrows at the end of an endpoint, it's just saying that we're looking at a full line. Okay, so let's turn the page, get onto the back here. We're going to look at how these rules translate into specific problems. So let's look at this same figure that we had from before. We've got lines T, M, and N. And these are angles 1, 2, 3, 4, 5, 6, 7, 8. And here we're told if the measure, oh, before I begin, I did make a mistake on this note sheet. Please note that 74 should actually be written here, not 174. So in the figure above, which I've moved over here, ignore the marking on the lines. So we can assume that the lines are parallel. If the measure of angle 2 is 106, so assuming 2 is 106, and the measure of angle 8 is 74 degrees, so this is 74 degrees. Can we conclude that M and N are parallel? Well, let's look at this. We know that angle 2 equals 106. And because of the definition of supplementary angles, we know that angle 2 plus angle 4 has to equal 180, right? Because they make a line together. Therefore, angle 4 is going to be equal to 180 minus 106, which is in fact equal to 74 degrees. So what we've just shown is that angle 4 is 74 degrees. Notice here that angle 4 actually then equals angle 8. They have the same measure, 74 degrees. And since angle 4 equals angle 8, we know that these corresponding angles show us lines are parallel. And that is just from the theorem that we talked about. We know if two angles that are corresponding angles share the same measure, the line has to be parallel to the other. All right, so we're up to slopes of lines. Now, you've probably dealt with slopes many times before, and you might know this rule. Lines are parallel if and only if they have the same slope. So there are a couple ways that they're going to give you to try to figure out if something is parallel. First is they're going to give you two formulas. If you're given two formulas and you want to find out if they are parallel, put them into slope-intercept form. It's going to be the easiest form to work with, and that's because of what it says right here, slope. We are looking specifically at slope. We don't care what the intercept is, but we do need to know that the slopes are the same. So slope-intercept form is y equals mx plus b. So what we need to do is start here, solve for y. Now I'm going to start by subtracting 2x from both sides. So I get negative 5y is equal to negative 10 minus 2x. My next step is to divide both sides by a negative 5. Remember, when you're dividing a fraction like this, you do need to divide negative 10 by 5 and negative 2x by this negative 5. And you'll end up getting this. Y is equal to a positive 2 plus a positive 2/5 x, which means the slope is 2/5. Now we need to check out this line. If it has the same slope, we know that they'll be parallel. So again, I'm going to start by trying to get y by itself. And I have negative 2y is equal to 4 minus x, since I subtracted x from both sides. Next, I divide by negative 2. And I get y is equal to 4 divided by negative 2 is negative 2. And negative x divided by negative 2 is a positive 1/2 x. And since this is our slope, we know that the slope of this line is 1/2. Notice here we have slope of one line is 2/5, slope of the other line is 1/2. Those are not equal. Therefore, we can conclude lines are not parallel. Now you'll also be given 4 points. If you are given 4 points, here's what you should do. Use the slope formula. This will be one of the few formulas I will ask you to memorize, and it goes like this: y2 minus y1 over x2 minus x1. That's the slope formula. You've probably used this before. I can tell you, you will have to use it again in algebra, so you might as well memorize it now. In order to do this, we want to first look at each line and find the slopes. I'm going to start with M. We're given 2 points, 115 and 230. I can pick either point as my x1 and y1 and x2 and y2. So I'm just going to pick them in order, where this will be my x1, this is my x2, my y1, and this is my x2 and y2. So now I just plug my numbers into the formula. We've got y2 is 30 minus y1, which is 15, over x2, which is 2, minus x1, which is 1, and I end up with 15 over 1, which is the same as 15. Now I look at slope of n. So n has the points 120 and 350. Again, either one could be my point 1 and point 2. I'm going to get the same answer. So I'm just going to go in order again. So my y2 is 50, and I'm going to subtract from it y1, which is 20. Divide that by my x2, which is 3, subtracted by my x1, which is just 1. This gives me the equation 30 over 2, which, when simplified, is equal to 15. And since both slopes in this case are equal to 15, we can conclude that the lines are parallel. Lastly, that brings us to a final idea, and that is the transitive property of parallelism. So when we talked about transitivity before, we talked about if A equals B and B equals C, then A equals C. The same principle applies to parallel lines. So if L is parallel to M, and, as you're going to see abbreviated, M is parallel to N, so M is parallel to N,